All right. Yeah. So far we have talked about like model input output chains and memory in the last few videos in this LangChain crash course series. And in this video, I wanted to take you through the concept of retrieval and how LangChain kind of helps us to like plug in extra data on top of the LLM. And I will also take you through the very basic concept of semantic search and how we can do in terms of code and implementation of semantic search. Right now, first of all, why we need a retrieval concept, right? So if you have seen, like ChatGPT has a cutoff date, like after September 2021, your model does not know what happened in the world, right? So it has a cutoff date, and also in some of the cases, your model is not performing well for a domain-specific data. For these two reasons, where like model is not aware what is happening currently in the world, and also when the model is not being trained on very specific domains. So in those cases, you need the concept of retrieval, where we will use external data and that we will pass as a context to the LLM to bring more meaningful information out of the LLM. Right. So the basic concept is external data is retrieved and then it is passed to the LLM during the prompt output generation. Right. So let's go and check like what are the different functionalities we should be aware of in case of LangChain while talking about this retrieval module. Right now, using LangChain, you can load different types of documents, which are like CSV, PDF, or Markdown, JSON. All these documents you can load using the functionalities of LangChain. And in some of the cases, you may need to install extra libraries like PyPDF if you are working with PDF documents. So once you load those documents, what the next thing what you will do is you will create chunks of that data. So why we need to create a chunks of data is because in some of the cases, these documents would be very large in nature, and you can access the content of the documents when we load the document, and then using the page content, you can access the document, and those page content can be very huge, and that can also exceed the maximum token length for any LLM, right? So that's why we kind of divide those documents into chunks using this concept of either character text splitter or token text splitter, which we will see in the code in today's video. And so once we load the document, then we divide the documents into chunks. So once we have the chunks, then we will create embeddings for each of those chunks, right? So you can either use a Hugging Face embedding model, which is like a sentence transformer, or OpenAI embedding to create the embeddings out of those chunks. And once we have the embeddings, then we can use a vector store to persist those embeddings into a vector store, right? So Chroma is one of the vector store we will use in today's video, and we will see how we can do a semantic search using Chroma. And like Pinecone is also a very famous vector store, which is also supported by LangChain. So basically, this is how the steps looks like on a high level. Okay, now let's go and visualize this whole process in a more systematic fashion. So at first we have our documents, which are like the documents which model is not aware of, right? Which is kind of a domain specific documents, or the documents which are more relevant to the recent times, which the model is not aware of. So once we have those documents, what we do is using the PyTorch the document loaders, we will load those documents, and once we load that, we will create the chunks out of those documents. Just as I mentioned, like the size of the documents may be very huge, and that can exceed the maximum token length of the LLM. So just to tackle that, we will kind of divide the document into multiple chunks, right? So once we have the chunks, then we will create the corresponding embeddings for each of those chunks using a embedding model. And after that, we will kind of store those embeddings into a vector store to persist those embeddings, right? Then a user will come up. User will come with a specific question, and what we will do is we will create embedding out of that question, and we will kind of do a nearest neighbor search, and we will try to like semantically, we will try to retrieve the documents which are very close to the actual question, right? And those documents will be also ranked. Like the most relevant document will have the highest order, and similarly, the other documents which are less semantically closer will be also retrieved using this concept of semantic search using vector store, right? So once we retrieve those, we will send back the results to user. So here there is no involvement of LLM. We are just using embedding model, and we are just doing a semantic search based on the question, right? So I hope you got an understanding like what the flow is of using a how we can do a semantic search using a vector store. And this is one of the facilities of LangChain. Okay, now let's go and see how we can do a code implementation using this concept. So this is the code implementation which I wanted to take you through. Few of the installations which are very regular in nature. So the extra installation which I am doing here is the sentence transformer, which is kind of the embedding model which we will be using, right? So once we have that, these are like the high level steps which we will go through. Like we will load a specific Llama 2 paper. So that is like there are several papers which are available as an archive to in Kaggle, and we will load one of the paper which is related to Llama 2. And once we load that using the LangChain document loaders, we will create chunks, then we will create embeddings, and then we will try to persist those embeddings using a vector store of ChromaDB. And after that, we will try to perform a semantic search, right? So this is how we are loading the document. We are using this LangChain.document loaders. We are importing the PyPDF loader, and after that we are just mentioning the path of that PDF file, and it's kind of creating a loader, and we can access the pages of those document using this load and split concept, which will kind of split the document into multiple pages, right? And if you go and check like how many number of total pages are there, there are 36 total pages. And after that, what you can do is you can also look into the metadata of each of the pages, right? So it tells you like the page is equals to 0, that is kind of the first page, and also it tells you the source of this page, right? And we can access the page content using like I'm accessing the first page, and then I am accessing the page content, which tells you like what is the content that is belonging to that particular page, right? So similarly, we will have page content for the other 35 pages of document. So once we have seen that page content, we can also see what is the length of a particular page, right? So here the length is like 3986. So this can be very large at times. This length can be very large at times, and this can exceed the maximum token length of a LLM, right? So what we do is we kind of create chunks of those document, and once we split the document into chunks, then we create an embedding out of it, right? So here I am using this character text splitter. And once we load the document, then what I am doing is I am just using this character text splitter. I am mentioning the chunk size is 1000, and also I am kind of doing a overlapping between the different chunks, right? So this will help us to give better results and contain the context of information between the chunks, right? So if there is a overlap between two chunks of then there will be a continuation of the text. So your LLM or any semantic search which you are doing there, it will try to see like if what is the continuity between the chunks, and it can give you better results for that. So we can see like there are around 27 total chunks which are there, and also length of a single document is 4056, right? So this is how we are using a text splitter. We will do this dot split documents, and we will pass the documents to that to get the text chunks of those documents, right? So we can also do a token text splitter. This is based on the Hugging Face library, which is tick token, and there you can mention the what would be the chunk size of each of those chunks, where it will kind of only contain each of the chunks will have a size of 500 tokens, right? So this is very specific to token related. Before that, it was like a character lengthwise we are doing the chunk. Here we are doing the chunk based on the token size, right? And after that, we can see like here we have like around total number of text chunks are 72 and the length of single document is 1859. So I just wanted to show you the two different ways to create chunks, and you can use any of this too. So we will go ahead and use the character text splitter, and after that I will try to create the embeddings, and I'm using the Hugging Face embedding and using the model which is sentence transformer. And you see also that you can also use the OpenAI embeddings. So this is the way to create a OpenAI embedding, and you can also use the embedding which is coming from the OpenAI models, right? OpenAI embeddings. Then once we have the embeddings, then we will like loop through each of the documents, and we will create chunks or create embeddings on the page content of each of those chunks, right? So here we have the embedded docs. Like there are total 27 embedded docs, which will be same as the number of documents which we had when we did the character text splitter, right? And each of this embedded docs has a length of 384. And if you want to like take the example of first embedding, and then you want to visualize the first 10 embeddings, these are the corresponding way to do it. Like we are visualizing the first 10 embeddings of my first text chunk, right? Then using a vector store, we will try to load those embeddings, and we will try to persist that. So what we are doing here is using this Langchain dot vector stores. We are importing Chroma, and using Chroma DB, we will create a DB where I'm mentioning what are my docs and also what are the embeddings model I am using, and also the persist directory, like where we are storing the Chroma DB, right? So you can save that DB to your local disk using this db.persist. And later point of time, when you want to access that, you can just load that folder, and then you can get back your embeddings using this command, which I have commented out here. Right now, you can do a semantic search without using an LLM. So you have a query, which is like, the query is how is Llama 2 compared to GPT-3? And we are doing a similarity search on the DB or the Chroma DB or the vector store, right? So here, using this db.similarity search, I am passing my query, and also I am telling in the semantic search that only fetch the 3 nearest neighbors or the 3 most relevant documents based on this query, and it will give you like 3 outputs on that. And this is we are looking one of the page content of one of the documents. This is how it looks like, and then this is the full doc result. So here it will have 3 page contents, and you can see this is how we can do a like a semantic search on a external document, and we create a chunk of those documents, and then we create an embedding, and then we can do a semantic search using this concept, right? So here I'm just looping through the page content of doc results, and we are kind of checking how each of this page content looks like, right? So yeah, this is all I wanted to talk about semantic search using a vector store in this video. And in the next video, I will take you through the concept of RAG, how we can incorporate the LLM using this vector store and embedding concept, and how we can do a retrieval augmented generation using an LLM and vector store. So thank you all. I hope you like this video. Please subscribe this channel if you haven't, and do share this content with your friends and colleagues. Thank you. Thanks for your time.